Hi, my name is Jason Nemick, and I work on the product team here at MongoDB, specializing in our cloud-native footprint. You know, MongoDB and Kubernetes have a lot in common. They are both cutting-edge distributed systems. They are both run on everything from Raspberry Pis to laptops to petabyte cluster scale. They are now today household brands which have paved the way and helped define cloud computing as we know it today. In this video, you'll get a quick review of the MongoDB 2021 Kubernetes product lineup, including a demo. MongoDB dropped our first operator back in the summer of 2018, followed up with an OpenShift Innovator Award from Red Hat in 2019, and today we have a stable of 3 operators and with a growing install base and backlog. But before we go any further, let's take a step back. So why even run MongoDB in Kubernetes? Let's start there. Why would you want to run MongoDB in Kubernetes? Usually the answer to this is simple. Kubernetes is where your apps are running. Apps have data and need databases. So sure, run your databases on the same platform. You might need to offer your own database as a service within your organization. This is a common practice we see across all our major enterprise customers. Finally, at the end of the day, you want all your apps working in a unified way, maintained with best practices, and you want to be taking advantage of all these advances in cloud computing to optimize your delivery and give your customers a great experience. There are trade-offs to consider, however. So maybe we could take a slight twist on that question. When should you not run MongoDB in Kubernetes? Well, if your data is in the cloud and you don't want to hassle with managing anything, then don't use MongoDB in Kubernetes. Use MongoDB Atlas, which is fully hosted MongoDB with every feature available. Now, if your data is not in the cloud and you do not want to run Kubernetes, then for sure, don't run MongoDB in Kubernetes. Run MongoDB on VMs or bare metal, and then use MongoDB Ops Manager to automate everything. Now, if you don't fall into either of those categories, then you should consider Kubernetes. And we have 3 different operators to satisfy those requirements. The MongoDB Atlas operator, a community MongoDB Kubernetes operator, and an enterprise operator. Let's have a look at the Atlas operator, our trial version, and have a demonstration of how that works. The MongoDB Atlas operator is based on the operator SDK. We recently released this version earlier this year. It's integrated with standard delivery methods for operators like Operator Hub, and we're focusing really on DevOps and stability with the first release of this operator. The MongoDB Atlas operator works like all the other MongoDB Kubernetes operators. The operator allows users to use automation and standard Kubernetes objects like custom resource definitions and secrets to allow apps to securely connect to MongoDB Atlas databases. So let's walk through what using the Atlas operator is like. There's 4 easy steps. We're going to create an API key, install the operator into a Kubernetes cluster, use it to provision a cluster in Atlas, and then finally connect up and out. So let's start by creating an API key. We'll switch over here to Atlas and log into one of your organizations into the Access Manager, and we'll create an API key. Give it a description. And we need to make sure we give it project creator credentials. Okay, so now let's capture this information real quick. I'll add an entry here for that. All right, so there's our public key, which we're going to capture that over here in a little script we have to install this. So there's a new public key. And we'll grab our private key. And our organization is going to stay the same on that. And click done. All right, so that's step one. We've created an API key. Now let's install the operator. Here's a little helper script to show you how to install the operator through our Helm chart. All the MongoDB Helm charts can be found on GitHub in this repository, which you can deploy directly from, or you can clone this repository. In this example, I've cloned the repository locally. And I'm going to run the following command to install the operator into the default namespace. At this point, we don't have anything in that namespace. Okay, now we can see that the operator Helm chart has been deployed. And if we take a look at the objects in the cluster, see that now we do have the Atlas operator up and running. And you can see the logs looking pretty good. All right, so there's step two. We've installed the operator. Step three, let's create a database cluster. For this step, we'll take a look at that script that I was just editing where we added the API key. Here, I'm going to install another Helm chart for an Atlas cluster, passing along that API key, as well as some information about the project we want to generate in Atlas to contain this cluster. So we can run this, and we're going to give this a name. How about Happy DB? We can take a look, and we can see now we do have two different Helm charts deployed, two different Helm releases. You'll notice here that the operator actually installed 3 different custom resource definitions, and we can take a look at the Atlas clusters right here. There we do in fact see the new one we just created. And if you can see here that it is creating. So we'll have to wait a few seconds for the cluster to finish creating. And when it's done, we'll come back and connect our application. All right, let's see if that cluster is up and running. First thing we can do is ask the Kubernetes cluster what's going on with that Atlas cluster custom resource. And we can see that it's up and running and we have a connection string. What's more is that Helm chart actually created an instance of an Atlas database user, and that created a secret, which we can now use to connect an app to. Okay, the app we're going to deploy is a simple app that deploys a Docker container running an implementation of the FastNight API Python app, and we're going to pass in that connection string through the secret. Here's a look at the Helm command used to install that. I've already deployed this because it takes a few minutes for the Elastic Load Balancer to give us a public IP. But we go ahead and see what we have here. You can see that there's a pod and a service running for the app. And you can see the 3 different Helm releases there. If we grab that IP address and go over here, we can see our app. And now we can actually read and write data into MongoDB Atlas. Let's try this out. This is going to create a simple little JSON document. I'll change this one and put John demo 123 maybe in there. Execute that. and it came back okay. We can go and say list, try it out, execute, and there's the one we just sent in. Now we can actually go into MongoDB Atlas and see these changes in real time. All right, here's the database. Go into collections. There's the students, and there's our 2 students from our sample app. So in conclusion, thanks. I hope you enjoyed this quick demo of how to use the new MongoDB Atlas CloudFormation resources. Thanks a lot.